Okay, so today we're going to do the last topic in chapter 3, which is elasticity of demand. This one is a really important topic because if you're an economist, you believe that the entire world revolves around price and demand. Price and demand. You raise the price, less people want it. People really want something, you can raise the price. It has that sort of feel to it. And so here's some examples. Increasing the price of a product can impact the revenue of the seller. So if you increase the price, it may result in sufficient decrease in the number of items sold and reducing your total revenue. So bottom line, if you have the price that's too high, not many people want it, your revenue is going to go down. But on the other hand, if you increase your price, that could lead to increasing the revenue, right? If you charge more for something, you're going to make more money. But it has an impact on demand, how much people want something. So it's the relationship between price, how much you're selling something for, and demand, how much people want it. So economists use the notation elasticity of demand to study the relationship between price, demand, and revenue. So we've looked at this relationship and we've boiled it down to a formula. So all this kind of stuff in between kind of gets you started there and get you an idea of where that formula comes from and how rates of change are. But it's all going to lead to a formula. So we're going to kind of jump a little bit right to the formula. And to find the elasticity of demand, we have this formula. And the formula is EP. Elasticity is E, P is price. The elasticity of demand, when you input price, equals negative. Now, it always starts with a negative. People forget the negative and it changes everything. So a nice way to remember that is generally, if you raise the price, you lose demand, right? So it starts out with a negative. It's a way to remember. You lose if you raise the price. P times F prime of P, so that's the derivative of demand, all over the original demand. So you need demand, you need price for all this to work. So the two things at play here are price and demand. And again, generally, if you raise the price on something, less people want it. If you lower the price of something, more people want it. Okay, some quick examples. If you have a lot of product and you want to get rid of it, what should you do? Put it on sale. Or what Publix is famous for when you walk in the door? BOGO, buy one, get one free. That's just a way to sell it. You think you're getting something for free, but really you're paying half on each price, okay? Now, there's a lot of psychology to this. Like if you ever buy, there's a cereal called Special K. Special K will never go on sale. And you're like, why not? Special K wants you to believe that the price of Special K is $5. So they will never go on sale because then you'll think, oh, I can get Special K cheaper. But Special K will do buy one, get one free. They gave you a free one, but the price was always $5. So there is some psychology involved with all this shopping stuff. This one is just focusing on price and demand, price and demand. But keep in mind, if the demand is really, really high, like right now, if you're watching soccer, Lionel Messi is playing for Miami in soccer. Ticket sales went through the roof, right? So that ticket that normally cost $100, you could sell for $1,000. You're like, wait a minute, $100 to $1,000, less people would want it. Not if it's an item that everybody wants. Does that make sense? So there's all these things at play, But this formula would be a very nice addition to our one page. But going back to our one page, remember, we talked about special case derivatives. We talked about derivative of E, derivative of ln, derivative of log. We talked about derivative of a number raised to a base raised to a variable, base raised to a variable. We talked about product rule. We talked about quotient rule. We talked about chain rule. So another one you definitely want to add here is elasticity of demands. And again, you can add examples. You can add whatever extra you want, but at least have the formula. At least have the formula. And the formula can be written a couple different ways, but that's the general form that the formula is written in. Okay, so this would be a good time to take out that one sheet of paper and make sure you have that formula. Yes, you can add an example. Yes, you can add more to it, but you definitely need that formula. You definitely need that formula. Okay, now there's a lot left to learn about elasticity. So the best thing to do is start with an example. So the price P and the demand X for a product, they don't tell us what the product is, but let's say that X is, let's try to do something that costs around $4, $16, $10. Let's call it a phone charger, okay? So X is number of phone chargers, and P is the price for a phone charger. So you started a business and you're selling phone chargers, but you're trying to figure out, based on demand, how much to charge for that phone charger, okay? And you are given the price demand equation to be X plus 500P equals 10,000. So you could be given it looking like this, but the way I would normally give it to you is as X equals. So I would do minus 500P, and you want it in the terms of X, which is demand, how many phone chargers, equals 10,000 minus 500P. Bottom line, you want it in the form where you can plug in for price, and then it tells you how many phone chargers you'll sell at that price. So this is the way we normally want our demand equation. Demand is X, how many, okay? So we want it to be X equals, not P equals or anything like that, okay? So the bottom line to this question is, how much do I charge for the phone charger? And you have a couple of guesses. Your guess initially is, I'm going to charge $4 for that phone charger. Well, I don't know if that's a good idea. So what we need to do is we need to find our elasticity of demand equation. So here's the general formula. Negative P times the derivative of demand over the original demand. So that's the formula. And we're going to slowly, carefully plug that in. So again, please feel free to ask questions. Raise your hand if I lose you at any point. Don't hesitate to ask. So that's the general formula. Now our job is to plug in. To find the elasticity of demand function, it always starts with what? Negative. So don't forget that. It always starts with negative. Then it always includes P, which stands for price. Now, right now, I don't know what the price is. I want to find the price. That's why I don't have anything for P. Then be careful. This is where we got to understand. The next part is derivative of demand. So the demand is right here. This is your demand. We're going to take the derivative of it. What's the derivative of 10,000? 0. What's the derivative of negative 500P? So be careful. Does everyone see where that negative 500 came from? Over the original demand, which is 10,000 minus 500P. If you did this, we'll simplify it in a minute. It simplifies to negative times negative is positive, 500P over 10,000 minus 500P. Now, we could simplify it a little bit further with factoring, but I don't want to worry about that right now. Let's just stop there and make sure we're comfortable on how we got that equation. Now, the question is, how much do I charge for this thing? I have no idea, right? I know my demand, but I don't know what price to charge. So your initial guess is to charge $4. So we're going to go into this equation and plug in 4. So I'm going to have 500 times 4 over 10,000 minus 500 times 4. Now, what I would do is I would put this equation in Y1, go to your table, plug in 4, and get that number, okay? But be careful, parentheses are very important in the calculator. Parentheses are very important in the calculator. Go to the calculator, plug in the formula, plug in 4, and see what you get. So your calculator steps are to go to y equals, and get rid of all the stuff that I got in there. And again, I'm going to be very careful. You can, the top you can put parentheses or not, but I'll just be careful. Put 500x in parentheses. It will work without because they're together. Divided by, and then the bottom definitely needs to be in parentheses, 10,000 minus 500x. Okay. Then when I go to the table feature, second graph, remember, be careful that you can type stuff in. Oops, second graph. Delete, 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 delete. When you plug in 4, you should get 0.25. 0.25. So make sure you typed it in correctly. You get 1/4, which is 0.25. And then you're like, what does that mean? Well, here's where you get to learn about elasticity. The way elasticity works is that if your elasticity is less than 1, between 0 and 1, but let's just say less than 1, if your elasticity is less than 1, you are inelastic. Inelastic. So if your result of plugging the price in is less than 1, you're inelastic. What does that mean? In this case, demand is not sensitive to change in price. That is, a percentage change in price produces a smaller percentage in change of demand. So a percentage change in price produces a smaller percentage change in demand. So what does that all mean? If it's inelastic, your answer should be, if it's inelastic, you should increase the price. Okay, so to keep it simple, if your result is less than 1, you are inelastic, you should increase the price. Inelastic, you should increase the price. So we plugged in our answer, we got a result of less than 1, and we're inelastic, so we say raise the price. $4 was too cheap. So we got a little greedy, and we said, okay, I'm going to increase it to $16. So go ahead and plug 16 now in and see what you get. When you plug in 16 now, because we went from 4 to 6, you told me to raise the price. Great, I'll raise the price. And so I raised it now to $16 for my phone charger. And now I got 4, right? 4 over 1, 4 over 1, which is 4. Now, what happens when your result is greater than 1? If your result is greater than 1, you are elastic, which means in this case, demand is sensitive to changes in price. That is, a percentage change in price produces a larger percentage change in demand, 4 over 1, right? So the idea here is that if your result is greater than 1, you are elastic. And if you are elastic, you shouldn't increase the price. You should what? Decrease the price, lower the price. You are way too high. Okay, and this happens all the time. Like when iPhone first came out, the price was high. People bought it, and then it stopped. They had to lower the price. Their price point was too high. The people went in and rushed and bought it, but that's it. Then they had to give discounts and give rebates. You want to pick the right price. So if we stop for a minute and think, Wait a minute. Above 1, bad. Below 1, bad. What number do you think we're trying to reach? 1. We're trying to get 1. And oh my gosh, how crazy is this? You just happen to guess $10. And when you plug in $10, what do you happen to get? Oh my gosh, how lucky are we? That when you plug in 10, you get 1. And what is 1? 1 is called unit elasticity. Unit elasticity. That is the goal. That is going to give you the best price based on your demand to give you the best revenue. Now, I don't know about you, but you're probably like, okay, what's the chance of me guessing this? Well, you could go to the table and start at 4, 5, 6, 7, or go down from 16 and keep playing with it. But does that sound like the best way to do it? No. The best way to do it is if you knew from the beginning what your equation is, and we now know what do we want this to equal. We want this to equal 1. Your job is to do the, what's the word that's been happening all semester? Algebra, algebra, algebra. So right now, I want you to solve this for P. And I will give you one hint. The one hint is I'm going to do 1 over 1. And remember, you can cross multiply, cross multiply, cross multiply. But do the algebra to find P. If you can't do the algebra, you can't find the best price. You can't continue with the problem. So if we cross multiply here, this would be 500p equals 10,000 minus 500p, add 500p, add 500p. You get 1,000p equals 10,000. Divide by 1,000, divide by 1,000, P equals 10. Now, we're not going to stop here because, yes, you just found out what is the best price per phone charger. What is it? Perfect. Now, the reason why we're not going to stop is I can also find the demand. I now know the price. I can go back to this equation. Which was 10,000 minus 500 times P. I can find what X is. All I got to do is take 10 and plug it in for what? P. So that would give you X equals what? 5,000. 5,000 what? Phone chargers. So you now know the best price to charge is $10. And you now know if you charge $10, how many phone chargers will you sell? 5,000. And then, don't say it out loud yet, you now can tell me what your revenue will be. You now can tell me what your revenue will be. Again, don't say it out loud. Give everybody a chance. Okay, so if you know price and you know demand, hopefully you remember that revenue equals price times demand. So if you're going to charge $10 each and you're going to sell 5,000 of them, your revenue will be $50,000. $50,000. Okay, so take a minute, look at this problem from start to finish. All I gave you was the demand. After I gave you demand, I said find the elasticity function. Once you found the elasticity function, you can plug in some values. You should be able to tell me, is it inelastic? Is it elastic? Is it unelastic? Then you can tell me the best price. then you can tell me demand, then you can tell me revenue. You can answer all of those questions, and all I gave you initially. So we're going to do another one of these from scratch, top to bottom, another one of these from scratch. Remember inelastic, elastic, unit elasticity, remember all that. And now we're going to work on this one, okay? So I'm going to give you that x equals 1875 minus p squared, or the same thing can be written as f of p equals 1875 minus p squared. So bottom line, I am giving you, as part of the problem, demand. I'm also going to explain to you that X is number of board games. So now you're in the board game business, and you want to figure out how much to sell your board game for. What you're going to have to do first is you're going to have to find the elasticity of demand function, which means you have to know what the formula is. So step one, find your elasticity of demand function. We'll label that 1. Let everybody write that down, because I'm going to scroll up. Then 2, I'm going to say, what happens when the price is $15? And what happens when the price is $40? You're going to realize neither one are good. So step 3, find the best price. Number 4, label your, I'll put it here, label your price, label your demand, and tell me what your revenue is going to be. Okay, so basically, just like last time, you're going to find the elasticity of demand function. You're going to tell me what happens at $15 a board game, what happens at $40 a board game. You're going to realize neither one's the best. Find the best price. Once you find the best price, I want to know the price, I want to know the demand, and I want to know the revenue. The price, the demand, and the revenue. Bottom line, we're doing the whole thing again with a new problem. All right, so let's go ahead and get started. Again, keeping in mind every word problem, we want to know what we're talking about. We're talking about number of board games. That's our X. P is the price per board game, being very clear about everything. You are given demand. Demand means you tell me the price, I'll tell you how many board games. Okay, so all that's given. Every part of it's clear. Because we're looking for elasticity of demand, you know to use the elasticity of demand formula. So you'll have that on your one-page of notes, and then we plug it in. So to find the elasticity of demand, it always starts with negative P, then the derivative of demand. Now be careful, signs matter. So the derivative of 1875 is 0. The derivative of negative P squared is negative 2P. If you forgot the negative, everything is wrong, right? That negative matters. Divided by the original demand, which is 1875 minus P squared. That gives us 2, negative times negative is positive, P squared over 1875 minus P squared. So if we got the elasticity correct, then we can move to the next step. So now we have our elasticity of demand function, which means we can start plugging in prices to see what would the best price be. Now, some of you are probably mind readers knowing that what's going to happen at 15, what's going to happen at 40, blah, blah, blah. But let's plug it in and be careful of little mistakes. When I plug this in the calculator, yes, the bottom has to have parentheses. Without the bottom having parentheses, it will come out wrong. The top is kind of optional because it's just one thing, right? But 2P squared. So we go to the calculator, we go to y equals, clear what we have in there, and we're going to put in 2x squared. If you have it in parentheses, that's okay. You don't really have to, but if you do, it's okay. Doesn't hurt it. But the bottom needs to be in parentheses, 1875 minus p squared, x squared in this case. Okay. Then let's go to the table. And our first is 15. So we go to the table, second graph, delete what we have. So your initial thought is to charge $15 for each board game. And if you do that, you get 0.2727. So when we plug 15 into our equation, we get 0.2727. Notice that E is less than 1. That is called inelastic. And what's the advice? Raise the price. So bottom line, $15 for our board game is too cheap. $15 for our board game is too cheap. Why is it too cheap? Elasticity is less than 1. Less than 1 means inelastic. Inelastic translates to raise the price. Okay. Then we said, sure, let's raise the price to 40. And when we raise the price to 40, we get 11.64, 11.64, 11.64. And notice that this time E is greater than 1. That means you are elastic and you should lower the price. So what did we figure out? $15 is too cheap and $40 is too much because the magic number is 1. The magic number is 1. So if we want to find the best price, which we could have just jumped straight to, you set your equation 2p squared over 1875 minus p squared equal to 1. Okay, and then when we work this out, 1 is really 1 over 1, so we can cross multiply. That will give us 2p squared equals 1875 minus p squared, add p squared, add p squared. Be careful. This is 3p squared equals 1875. Divide by 3, divide by 3. P squared, I can make that a little bit larger for everybody. P squared equals, what do we end up with? What do you get there? 625? 625? Yeah, 625. And then when you square root, yes, you will get positive and negative. But if we're talking about price, it has to be what? Positive. So we find that the best price to charge is $25. But before we move on, can I check that? How do you check it? Yeah, go back and check. So I go back to the table and we go to the table and we plug in 25. And yes, 25 is the best price. 25 is the best price. Okay. So after doing all this work, we found that our board game, the best price to charge is $25. But we do have all the pieces to find out revenue. Well, if you want revenue, you need price times demand. So we have the price. To find the demand, we're going to go back to the original formula, 1875 minus p squared. So f of 25 equals 1875 minus 25 squared. If you put that in the calculator, and I'll put it in, $1875 minus 25 squared at $25, you get 1,250. 1,250 what? That's how many board games you're going to sell. So now you know that the price is $25 and you're going to sell 1,250 board games. Okay, and then to find revenue, we just have to take the 25 times the 1,250 because each one we're selling for $25. And if we sell 1,250 of them, we will have a revenue, a maximum revenue of $31,250. $31,250. And again, all this can be written up in a sentence and all that. But again, look at it from top to bottom. Make sure every piece, every part of that makes sense. Makes sense. So to kind of summarize, remember, if the demand is inelastic, consumers tend to continue to buy even if there's a pricing increase. In this case, a price increase will increase revenue and a price decrease will decrease revenue. If demand is elastic, customers tend to reduce their purchases if there's a price increase. In this case, a price increase will decrease revenue and a price decrease will increase revenue. Okay, so it kind of gives you a nice little idea. And again, there's more problems that you can work on. This one talks about sunglasses. And remember, the nice thing about the notes is they have the solutions to the matched pairs problems. Okay, and that ends chapter 3. And we have this really nice, really long test review that I just want to talk a few minutes about. Notice the theme of the test review is special case derivatives, word problem with special case derivative, and this one includes exponential regression, so a little extra work there. And then we have product rule, and again, it starts a little bit easier, gets harder each way, incorporating some special case in there. Word problem with product rule. Quotient rule, again, getting a little harder, mixing everything in there. And then word problem with quotient rule. Chain rule, again, starting easier, getting a little bit harder as we get further down, a bunch of examples. And then word problem, be careful with this one, word problem with chain rule. And then we did related rates. The first one's the classic type related rates problem. Notice the structure, notice the setup, notice the way it's written, all of that. And then the same related rates, but with revenue as we did in class, number 10. And then the one we did today, elasticity of demand, kind of the same structure, having you interpret, having you write sentences.